Counting with combinations. Well, what's a combination? Well, a combination is an arrangement of a set where the order does not matter. So think about you're in a class and the teacher says, 2 students get bonus points. I'm going to pick names out of a hat. First 2 names I pick, you both get 2 bonus points. It doesn't matter if you're the first or second student chosen. Either way, you're getting bonus points. So if the order doesn't matter, we're dealing with combinations. All right, so a combination has the formula NCR. Sometimes people say N choose R, where N is the total number of things or people we can choose from, and R is how many we want to order, or how many we want to be in our group. I guess maybe group is better than order. How many do we want to group together? So that's kind of the key here. And we have the formula N choose R is going to be found by taking N factorial over R factorial times N minus R factorial. Okay, and this will make more sense when we throw some numbers into it. So 30 students in a class and 2 are selected to be student helpers. How many groups of 2 could we have? So you read this question and you say, okay, it doesn't matter whether you're chosen first or second, you're still going to be a student helper, so this is a combination. So I've got to think NCR. 30 students can be chosen from, so N is 30, and we care about 2 because 2 are going to be student helpers. So in our formula, we would say 30 factorial over 2 factorial times 30 minus 2 factorial. And before you start freaking out, I have 2 things to say. 1, some calculators have buttons for this, but 2, watch how I can manipulate this down into be something very easy to work with. Okay, 30 factorial is the same as 30 times 29 times 28 times 27, all the way down to 1. 2 factorial is 2 times 1. And then 30 minus 2 is 28, and that's factorial. So 28 times 27 times 26, all the way down to 1. And you're going to notice that 28 down to 1 cancels out with 28 down to 1. So I'm left with 30 times 29 over 2 times 1. So if you've played with permutations, you'll notice that this starts the same way as a permutation. I start with 30 factorial and I do 2 numbers. So 30 times 29, that's 2 numbers. And then I divide by 2 factorial. And that will always work. Now, when I come back to this problem over here, I can see that 2 goes into 30 15 times. So I can even simplify this further and go 15 times 29, which gives me 435. So there are 435 different groups of 2 student helpers that I could use. The reason we divide by 2 is because we don't care who's chosen first or second. So we got to take out those duplicates, right? If kid A is first and kid B is second, or if kid B is first and kid A is second, we still have the same 2 kids. So by dividing by 2, we get rid of all of those overlaps. All right, let's do another one. 20 high school seniors submitted essays. 4 winners will be announced, each receiving a $1,000 scholarship. How many different groups of 4 could there be? Again, we don't care if we're first or fourth. Either way, we're getting a $1,000 scholarship. So we have 20 students. We don't care about the order, so it's combination, and we care about 4 of them. So let's look at this. 20 factorial over 4 factorial times 20 minus 4 factorial. Okay, so 20 times 19 times 18 times 17 times 16 all the way down to 1 over 4 times 3 times 2 times 1, and then 20 minus 4 is 16, so that's 16 times 15 all the way down to 1. So again, 16 down to 1, 16 down to 1, they go away. So I'm left with 20 times 19 times 18 times 17 over 4 times 3 times 2 times 1. Now, if you're using your calculator, this is a lot of math. But, like if you're just using the combinations button. But if you're not, sometimes reducing your fractions first makes it a little bit easier. So I know that 4 goes into 20 5 times. 3 goes into 18 6 times. 2 goes into 6 3 times. So now everything on the bottom is a 1, and I have 5 times 19 times 3 times 17. And when I multiply those together, I get 4,845. So that's how many different groups of 4 we could have to win this $1,000 scholarship. All right, let's do one more. That's exciting. A committee is made up of 12 people aged 50 and older and 16 people under the age of 50. The committee needs to send 6 people to a conference. How many ways can they send 3 people aged 50 and older and 3 people under the age of 50? So this is like a combo question. We're saying, okay, out of 12 people, we want to choose 3, because again, we don't care, right, what order they're in. And out of 16 people, we want to choose 3. Because, right, we're taking the older 50 and older population, we want 3 of them, and then the under 50 population, we want 3 of them. So I'm going to use my shortcut way. For 12C3, that means I'm going to do 12 times 11 times 10, just 3 numbers, and I'm going to divide by 3 times 2 times 1. So remember, I start with 12 in the numerator, 3 numbers, 12, 11, 10, and then I divide by the 3 factorial. On the right side, I start with 16, think factorial, but just 3 numbers, divided by, again, 3 times 2 times 1. And now I can simplify. So 3 goes into 12 4 times, 2 goes into 10 5 times. So I'm left with 4 times 11 times 5. In the right, 3 goes into 15 5 times, 2 goes into 16 8 times, 8 times 5 times 14. When I multiply those all together, I get 123,200. That is how many different groups of 6 we could have if 3 are from the 50 and older age group and 3 are from the under 50 age group. That's a lot of different groups. And that is playing with combinations.